We're going to take a quick look at a very kind of common problem that you may encounter with particle simulations, something that has a bunch of different techniques and ways to solve it. I'm going to show you one, and hopefully it'll spark some ideas for how you might solve this on your own. But this is how to use outside controller objects to affect what's happening in your simulation. And for this example, what we're going to do is we're going to take a look at how we can use controllers to choose which part of the simulation are going to dissolve off into like a dust-filled simulation. So what we have here are our initial points scattered already on our geometry. And when we go inside here, what we can see is we have this set to all points and our birth is only on the first frame. I'm going to turn off our guides here so we can accurately see that. So what I like to do is use a special metaball setup here. And I'll show you how this works. We're going to add in 2 points here, and we will kind of move the start of our system over here. And what we'll do is we'll copy a metaball onto this. Excuse me, not a merge. I would like to copy to points. All right, these are our metaballs. Metaballs are cool because they start to blend together when you get them close to each other, so you can get some really nice organic effects this way. But what we want to do is use this to influence the points here. So I'm going to use an attribute VOP here, and I'm going to wire our points into the first input and our metaballs into the second. And we'll take a look here. So we have a special VOP called a metaball weight that we can use. We can grab the metaballs from our second input here. Our lookup position is that first input. And we can take this metaball weight and we can visualize it here with color. Okay. I like to bind this to an exported attribute here. So I chose bind export. And I'll wire this in and we'll make an attribute here called effect. So all that does is create an attribute called effect on here, which is going to be equal to the output of that metaball field. And then from here, we can actually grow these metaballs. So I can put an attribute, adjust float here, and we'll have it adjust p-scale. And I'm going to choose set always. And now we'll just keyframe this. So we'll go to like 48 frames and we'll just grow it. Let's say only to about here. Now, I mean, it's pretty blobby looking, but let me show you one thing that we can do to affect this here. So if we modify our lookup position, we can actually modify how that looks. And then we can add some noise into our lookup position. So all we have to do is take our position here and add in some noise. So I'm going to do a very fast noise here called turbulent noise. And I will wire our position into here and make sure that is set to 3D. And I'm going to choose a sparse convolution noise here. Wire that in, and then take the sum and wire that into our new position here. And you can see now that we have noised up that lookup. And we can promote this stuff. So I'm going to promote everything here. And now when we go up here, we have all of these things here that we can play with. So we'll go ahead and get something that looks kind of natural. All right, so that is our control here. And I'm going to put a null and label that control. So the important point here is that this has the same number of points as our particle system. So we can do a one-to-one lookup. I'm going to wire that into our pop network. And now what we'll do is we'll put a pop win down. And at first, we'll just put, like maybe 2 in this direction, 2 in this direction, and some amplitude. Let's make our swirl size something like that. I don't know. A little more roughness. This isn't really that important, to be honest, in terms of adjusting some of this stuff. Kind of just playing here. All right. But what we want to do is control this with that effect that's coming in. So what I'm going to do is put a pop wrangle down here. And we're going to change our input, number 2, to the second context that's coming in. And all we need to do is make an effect, make an attribute here called effect. That's a copy of the attribute from that other stream. So at effect is going to be equal to, and we'll use a point lookup here. So point, our second input, the name of the attribute was called effect, and we're going to set it equal, the point lookup is going to be our current point number. Now this doesn't work if particles get killed. So if we really wanted to, we could change that to ID. And if particles die, then we'll be fine. We just can't birth new particles in. It's going to screw up this system a bit. And then we can actually kind of soft modify this a bit. So we can do a hard modification and actually make a group and say, like, if effect is greater than 0.5, then you're part of this group, for wind, and then that gets picked up in here. Or we can actually make it a little bit softer and kind of nicer to look at. And we can just start modifying, some of these values here by that effect value. So what I'm going to do is modify the wind velocity by effect. So if I hover over here, that's going to be called wind, either XYZ or just wind on its own. I'm going to say wind is times equal to our effect. And then I'm going to go down into the noise parameter here, and I'm going to affect the amplitude as well. So let me hover over that. That's called AMP. So amplitude is going to be times equal to our effect as well. Now when we play this back, you can see how we've used that attribute here up in our SOP network to really nicely control how this is working. And the great thing with this is it is fully procedural and customizable. So, we can always add another point in here, and, maybe we'll put this somewhere around here, and we'll go to our P scale, and let me just go over like here, and we'll set that equal to 10. And now take a look at our simulation. Right, looking pretty good. And again, I'm not really tweaking any of this stuff here, but you are certainly welcome to tweak it until it behaves the way that you like. The point being that, you're making something that is looking good to you, and that you're using the systems that we're building to control what's happening inside your simulation. And again, the whole point is giving you control. It's giving you the ability to make what you envision in your head, or, what an art director is asking you to do.